So I decided to do end-to-end pipeline, which doesn't mean, reading data set and, end is at the training the model. But because I'm doing it on Kaggle competition, that end means it is actually submission on Kaggle. And over a time, then you can change and improve the model. But then all of this end-to-end pipeline, it remains same, and all the changes you can do just here. So I divided that into these five stages, from data set to model to training to experimenting to final submission. Okay. And for that, this I thought this was a good structure. Any structure, just start with it, something which is good to understand, to you. So I put a data set as a folder here, and in this data set folder, I reorganized the data set from Kaggle competition. Okay. Here in the training directory, they had all the images, and they had a separate file in which they had the name of whatever that class was there. Okay. But instead of that, what I've done is I have, using some Linux programming, how it doesn't matter. What matters is I have gotten it into this format where the folder name is the class name. Okay, so that by checking into any folder, we can see in one place what this specific thing, dog breed, looks like. So, terrier, all the terrier images in one place. So, we can see the variations between them. We can then change our thing accordingly. And this format allows you to just load it in one sentence, just one sentence. So that is why what I decided to do, divide it into these sections: data set, experiment. Generally, in deep learning, we have data, and then data we pass it to untrained model to get trained on that data. So data model, and this combination of do running this experiment is the experiment. Okay. So these are the directories, and if you have some utility scripts, there is a lot of fuck all code you have to write, tiny bits. Sometimes it works, sometimes it doesn't work, different versions. So all of that, I'm like, you know what? Let's put it all into scripts. And here also training, for training, let's have a separate code. And all the models, their architecture, it all goes here in this models. So by following this structure, I thought it will be easy to, maintain and look and everything. So that's what I decided to do for this end-to-end thing. So modified it to got it into format, and then its consequences, then just this one line thing. So if you check tf.keras.utils, this is the function call. And here there are two ways of calling this function. We have this image dataset from directory, which is present in Keras utils, or we also have it inside keras.preprocessing and then image dataset from directory. TensorFlow has a lot of these things, different function calls, but they all refer to just one and the same thing. So it might make it easier to remember or difficult to remember depending on how you look at it. But for me, it's annoying, two different ways of doing the same thing. It makes me confused. So this is in one line, you can read it. Okay. And there is some of the exceptional behavior. I have included those in comments. So here in this function call, there were a few problems I found. Even though this is done just in one shot, it has this image size as a default value in its documentation. Its default value is 256, 256. So if you are reading any image, it is going to resize it before, because by default those values are taken. And I thought that was a weird thing. This thing might lead me to, I'm like, what the hell is happening? Where is the resize happening? So another problem was, I wanted to convert this data set into training and validation for separately. I could have also done in the directory itself, separate directory for training, separate for validation. I should do it, but here in this function call itself, there was a validation split utility when I was checking the documentation. So I was like, you know what, let's use this. And then while doing that, I realized if you're using this, you have to specify subset, you have to specify seed. These were the to and fro permutations I had to do to find this out. It is not easy. And then it also has batch size. this data set, it automatically reads, takes a batch size. So anytime we take an example, it is gonna be group of those many examples. So here it takes 32, and each image, black and white image, has just single color thing. But the images which we see, we deconstruct them into primary colors, RGB. So each is separate channel. So here that mode is color mode RGB, which means three channels for three different subcomponents. So lot of things not that easy to read, but it gets everything done in one shot. And here in this test one, I have put in some asserts. So easy way to get an example and actually play with it is you could call these functions. You have to probably remember them, take and batch. Take means take these many examples. Batch means give me two batches. So take 10 takes 10 as examples. Batch 2 takes 2 as number of batches. And each batch is going to have certain number of examples, which is equal to batch size. So you see, there is a lot of internal in your brain. You have to do these calculations, a bit counterintuitive. I found this to be easiest. Convert the dataset into a iterator and then just call next on it. This works in PyTorch, this works in TensorFlow, and because this is a Python thing, it is not dependent on the internal library function calls. So I think you can do this in other Python libraries as well. A good standard way of doing things. So I convert into this, and then its zeroth index is image and label. So here for image, I took the shape. I called the shape function and called the length function on it. So the length of this would give me actually the same format length as these four characters, BCHW. So whatever is this length. So the format of all images is generally, images are two-dimensional images. The third dimension is its subsequent colors, which we deconstruct into R, G, and B. So B stands for batch, C stands for channel, H for height, W for width, and the length of image should be same as length of this. So zeroth index here me is 32, which is batch size. First index and second index. We don't want to include the third index. That's the Python slicing thing. Simple way to check this length is 3 minus 1, 2. So its length is 2, which is 224, comma 224. That's how we have formatted them to be. And then shape is equal to 3. So I did that in this data set, and this 20% part of data set is done. Training and testing split into validation with image folder, and this done. And then second was a simple model. So model I have written to extremely simple. It is so dumb and so simplistic because my focus is end-to-end pipeline. I'm going to take a simple model, which is just three layers. First input layer, which takes an image. Then we have one hidden layer, which contains 240 neurons. And then we have a single output layer, which has 120 neurons, which is same as number of classes. 120 is same as number of classes. Simple network. Just one hidden layer. It's code input for input, and then here converting into image, converting it into this linear format, 2D format. We call this flatten. Keras has flatten directly available. In PyTorch, you have to write it. So different behavior in these two libraries. So do it in, then call a dense layer, fully connected layer, which is 240. This is the first hidden layer. And then the final output layer is another fully connected layer with 120 neurons. So this is the extremely simple neuron. This is how I have written the code. Simple class, simple model. Initialize, this guy itself has internal model. So I do it tf.models.sequential. And the forward pass here internally is done like this. Get the internal model from, self dot, we can simply say, I want to actually call this thing, which is defined into initialization function. So using self dot, I call the same value which is present here, right? So get output and get it returned. So this is as simple as that. Okay, so I write a simple batch using random thing, and I call it into the forward, and I do quick testing here also. Okay, is the output into the format I want? Generally, output output of this dense layer is going to be same dimensions as number of neurons, which is number of classes in this case. So we do that check, and this simple code is also done. So going back to the thing, end-to-end pipeline, dataset and model is done, and next part was training. So for the training part, I was doing simple default training thing, which is keras.fit, but that thing is giving me some error. So this just proves that even if you define it properly, the getting it to work has a lot of annoying bits to make it work. So it is good if you organize it into this end-to-end pipeline, and once you have a steady pipeline, then you can improve on the model, to do that end-to-end flow first. So here, this was giving me an error. Now I will spend time figuring out why this is happening. And once that is done, I'll have the end-to-end code. So conceptually, deep learning might be easier, but programmatically, it's lot of tweaking of code you have to do. So you can take help of ChatGPT, or you can also build your own understanding, which is a lot deeper, which allows you to do these things. So, but follow the right methodology. So I'm following the structure, end-to-end pipeline, and this thing. So today, by the end, by following this format, I want to get there, and I will do some iterations, and I will keep uploading the progress here.